My name is Shiva Singh. Today I'm here as your teaching assistant for course Organometallic Chemistry. Today I will be addressing assignment number 1 and of year 2023 and assignment number of 3 of year 2022. This course is coordinated by Professor Debabrata Maiti at Department of Chemistry at IIT Bombay, and I am a PhD scholar at Department of Polymer and Process Engineering IIT Roorkee and Department of Chemistry at IIT Roorkee. And my thesis is supervised by Professor Pradeep Kumar Maji and Professor Kaushik Ghosh. So, before I start, I shall tell you the outline of the lecture. Firstly, I will be giving you my introduction, and then we will be discussing about the solutions of assignment number 1 of year 2023 and assignment number 3 of year 2022. I will be also telling you the basics involving in it, and I will explain those basics. So, my name is Shiva Singh, and I am a PhD scholar at IIT Roorkee with the Prime Minister's Research Fellowship. And I have did my masters in chemistry from VNIT Nagpur, and I have did my graduation honors in chemistry from Kirurimal College, University of Delhi. My higher secondary and secondary education have been done with the State Board of Uttar Pradesh. And during this educational tenure, I have did three internships and project. One internship at Delhi University with Professor Akhilesh Kumar Verma, one internship with Professor Alakesh Visai at IISER Bhopal, and one research project at VNIT with Professor Chayan Das. During my educational tenure of PhD, I have published nine papers. Currently, recently this article have been accepted, and I have also published three book chapters. I have got Prime Minister Fellowship, Inspire Fellowship, and SN Bush Scholarship, and I have attended around 10 conferences and webinars. So after that, let's start with the assignment number 1 of year 2023. So the first question is very interesting question. Which of the following complex has the highest oxidation state of metal? Also, this is a confusing question, and I will tell you a logic which will open your eyes how to approach the question. So first, you need to go through the options and tell me what is the highest oxidation state of metal here. Think it is recording. You have 1 to 2 minutes for this question. I need to just. It's going right. Yeah, fine. Okay, we have got an answer. So answer is two. How come? What metal you are considering? Uh, it is iron. And how much oxidation have you got for iron? Two or minus two. Okay, Fe plus two. No, 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 no. If we come here, see, these are the solutions. Fe is coming minus two. But there is one key thing. The sodium, sorry, give me 1 minute. It's pen. Right. This sodium is also a metal. It is having Na2 having 2 plus. So I was confused with this question. Whenever I have calculated, I got Fe minus 2. The answer is third one, and oxidation state is plus 2. Okay, let's move to the next question. This is a similar question we have discussed in the previous session. Number of metal-metal bonds in iridium 4 and CO12. You need to do the calculations with that formula I have told and let me know the answer. Yeah, the answer was correct, third one. You have 2 minutes for this question. Number of metal-metal bonds in iridium complex is. Number of metal-metal bonds in iridium complex is 4, 5, 6, 8. We need to count total valence electrons, and we need to use that formula which I have told in the previous session. Also, few of the questions will be related to the my previous lectures of metal mediated synthesis, and so maybe you need to go with those sessions also. I will tell when it is utilized. Okay. So tell me the answer for number of metal-metal bonds in iridium complex. Shall I show the calculations? No, no, do not hesitate. Uh, you can directly tell me or ask me to tell the calculation and all. Yeah, sure. Total electron counts first. 9 for iridium into 4, 36. 12 CO of contribution of 2 electrons, 24, total 60. Okay. Number of metal bonds, 18 into number of metal centers, 4 into total electron count. So 72 minus 60 by 2. 12 by 2 means 6 is the correct answer. Okay. Got it? Is it clear? Is it clear? Shall I repeat? Shall I repeat? Okay, okay. Let's move to the next question now. This is again a repeat question, similar type of question we have already discussed in our previous session. So I will expect you to answer this question. Which of the following is a neutral complex which follow the 18 electron rule? So directly what you have to do, I'll calculate the electron count and tell me which is a neutral complex. Which of the following is a neutral complex which also follows 18 electron rule? Okay, we have got answer 4. Okay, let's discuss. These are the calculations. So you have already did the correct calculations. From your answer, I can infer that. Is the calculation is clear? Shall I move to the next question? Okay, let's go to the next question. In the complex of tungsten, it follows 18 electron rule. What is the hapticity of Cp? Again, you need to do the calculation with the 18 electron rule and tell me the answer. So there are two CPs, and I am telling you that they will not contribute equally. You need to tell which CP is giving how much hapticity. In the complex of tungsten, it follows 18 electron rule. What is the hapticity of this CP in this complex? Okay, 8 shared by 2 CPs. Okay, so 8 shared by 2 CPs, that means one CP will be contributing 3 electrons and another CP will be contributing 5 electrons. Okay, so it is 3 and 5. Option will be second. Okay, they cannot equally share. We know that it can only share 1, 3, or 5 electrons because the I think pentadienyl ring is like this, right? So if it is whole, then it is contributing 5. Okay, So if the charge is here only, then 1, and if it is like this way, then 3. Okay, this is the calculation. 6 for tungsten, cp2 is will remain like same. So cp2 is getting 8, 3 and 5. Okay, understood? Is it clear? Shall okay, let's move to the next question. The rate determining step in the octahedral complex substitution is believed to be an associative, dissociative step, and interchange step. This question is also confusing to me. Okay, according to me, it should be associative. Okay, but I will explain how it will be. Tell me the correct answer. I will explain like what the steps are and the mechanism and all. Okay, but still I want to hear an answer from you guys. Okay, let's go to the complex substitution. There are three type of substitution. Okay, dissociative, associative, interchange. Okay, dissociative, what will happen? Initially, this one will leave the octahedral complex. That means stable geometry is distorted. Okay, so it will be a slow step because it is going to the unstable one, higher energy complex. Okay, similarly in intermediate also association is happening. Then again the geometry will be changing of octahedral. Okay, so what will happen? Again the energy is increasing. Okay, so in which step the energy is increasing, they are the slow steps. Some okay. Then next, again interchange. Okay, that means one is coming, one is going out. These are the three type of substitution can happen in the metals, and these are the rates. Okay, the rate determining step is the slowest step of the reaction. Whenever and when the slowest step is happens, whenever it requires energy, that means it is not going forward, we need to push it. Okay, so it can be like, according to me, it can be all of three. But yes, in the references it is given as the in associative step. Okay, I do not have explanation for this. Okay, shall I move to the next question? Why does solvent polarity not affect the oxidative mechanism via concerted pathway? Oxidative addition, oxidative mechanism whenever happening via concerted pathway, why solvent polarity is not important in that case, or why it is not playing any vital role in the reaction? Do we have an answer for this? Why it happens? Is it a neutral intermediate? Is it a polar intermediate? Or solvent has no role? None of the above. For this, yeah, sure, I will explain. So what is happening in the reaction? Suppose solvent has no role, it is directly like it can be boycotted. Fine. Polar intermediate, suppose if there is a polar intermediate and they are saying polarity does not affect, but whenever the polarity difference, it will affect. Okay, so it is again not possible. Now we have two options. Okay, So suppose if there is a polar solvent but the intermediate is neutral, obviously it will not affect the reaction. So that is the explanation. Concerted pathway, this is the way it will be happening. No change in the generation in the transition state, so no solvent coordination will be happening with the metal. Okay, so there is no chance to change or affect. Getting my point? Because there is no chance to solvent coordination with the metal. So if solvent is not coordinating with the metal, how it will affect? The question was solvent polarity will not affect oxidative mechanism. Why? Because it is not involved in the coordination. Rather, it is providing a medium for the reaction. Understood? See here, in this mechanism, solvent is not involving at all. So if it is not involving, how its polarity or polarity will affect the reaction? That's why it is not affecting. Also, if we see here, you can see in the transition state there is no charge generation. So again, there is no polarity in the in this intermediate. It is neutral, so it will not be affected by the polarity. Okay, let's move to the next question. Rate of the reaction is, so they are saying it is a SN2 pathway. Okay, and I want the answer from you. If you are not following this complex or metal complex, directly go with the organic reaction and see the SN2 mechanism. That also can give you the perfect answer. Mhm. First order with respect to iridium and first order with respect to me. Okay, fine. The answer is correct. See here. This is the rate of the reaction. Question number 8. The above one. This one is the solution. ठीक है. And if we see it with the SN2 type of mechanism, see here. Each time when the reaction is happening, one of the this and one of substrate, they both are required. A nucleophile and substrate both are required. One and one. Okay, that's why order one and one. Let's move to the next question. Which ordering correctly describe the tendency of a ligand to direct ligand substitution in square plane complex to a opposite position itself? Suppose someone is here and there is a metal and its opposite position, the similar type of this ligand is coming. So what will be the tendency? What will be the order? As much I remember, the answer will come from the trans effect. Do we have an answer for this question? Okay, let's move to the solution. So if we see here, ligand is pi bond donor. Okay, because of its trans effect, the trans effect increases the rate of substitution. Okay, so the sequence will be Cn will be the highest, then Na2, then Br negative, then NH3. The decreasing order of pi donation tendency will give you the answer. Trans effect increases, so rate of substitution increases. Understood? So the correct answer will be this one. Okay, let's move to the next question. How many bridging ligands are found in Fe2CO3 CO9? Such questions will definitely come in your exams, or exams like GATE, NET, or your NPTEL exam. Do we have an answer? You can directly go for the metal metal bond calculation. No, no, no. So what will happen? You need to first check metal metal bond. Okay, how many metal metal bonds are there? So if you go for the calculation, you will get to know there are no metal metal bond in this complex. Okay. So what will happen here? Three COs, three COs, and three COs. Both two of the Fe's are in octahedral geometry by the bridging of three COs, and octahedrals are the stable geometry for Fe. Okay, we cannot put a direct formula for this, but yes, we can infer by the calculations that if there are metal metal bonds. So first you need to make metal metal bonds. How many metals? Okay, this much of the metals, and they will have this much of bonds. Okay, then you can decorate the ligands according to the stability. That is an approach to solve such questions. So how many bridging ligands? Three. Understood? Am I clear? Okay, let's move to the next assignment. Assignment number 3 of year 2022. Which is the correct product for the following? Do we have an answer? Six is missing. Yeah, I haven't answered the sixth one because I was not able to solve it. Like I have the answer, but I do not know how to explain it. So I am finding for the explanation. Actually, the explanation is there in book Ilias. Do you have Ilias? Page number 143. You can go there. Okay. Whenever delta S is negative, it will be associative. Whenever delta V is negative, it is associative. Okay, whenever delta S is positive and delta V is positive, it will be dissociative. Okay, a proper explanation is on page number 143 of Ilias for question number 6. Okay, that is what the question is now. Shall I move to the next? Yeah, it is the next question. I have told you the answer. For associative we need, negative delta S and delta V. For dissociative we need positive delta S and delta V. And for understanding, you can go through page number 143 of Ilias. This is the reference for the question. Let's move to the question number 1 of year 2022, assignment number 3. Which is the correct product for the following reaction? Do we have an answer for this? Okay. So this will be the answer for this. Okay, I will tell you the reason why this is happening. Okay. The positive charge was there. The methyl was supposed to come here, but it didn't. It came at this position. How come? That I will explain. Okay. See, there are three rules, three scientists, Davis, Green, and Mingos. They are called DGM rule. Okay. Nucleophile attack occur preferably at even coordinate polyenes. Okay. So what will happen if there is a polyene? So what will happen? The nucleophile will attack where? At polyene. See here. In this case, nucleophile attacked here. And then what happened? These two reacted here. See? Similarly happened here. Nucleophile attacked here and hapticity went to 3. Okay. Nucleophile addition to open the coordinated polyenes is preferred over the closed polyene. Okay. In the case of even open polyenes, nucleophilic attacks always occur in the terminal carbon atom. So whenever there is a polyene, okay, diene trine systems, the nucleophile will attack on the polyene first. Okay. And for reference, you can go to this book, Elias. Okay. Page number 112. Understood? Okay, let's move to the next question. The following transformation proceeds by reductive elimination followed by alpha migratory elimination, alpha migration elimination followed by reductive elimination, beta migratory elimination followed by reductive elimination, alpha subtraction followed by beta migratory elimination. So here rubidium is our metal, two ligands, carbonyl. Okay, carbonyl is leaving, and so do we have an answer for this? Do we have an answer for this question? Okay, we have got answer for this. Let's see how it is happening. So first what will happen? CO is at the alpha position. This R will come here. This CO will leave. Okay. This is what happening here. So what is happening? Alpha position by elimination is happening. Okay. Alpha migratory elimination. Fine. Then what is happening? RH. Okay. These R and H is getting out. We have to see the products. Where is the feasibility? This R and H cannot come out. Okay. But this CO is more stable, so it can go out and R will come here. That means alpha position पे elimination हुआ and जो R group है is migrated here. Fine. So that is called alpha elimination migration. ठीक है. That means alpha migratory elimination. Then again RH are the stable complexes compound, so it will leave. Relative elimination will occur, vacant position, and ligand will come here. Okay, so this is your complex. This, and this are the products. Getting my point? So that is why the correct answer is understood. How it is happening. Okay, so you need to see the products first and see how they are coming out from the complex. Then you will be able to understand what is happening in the reaction. Okay, so this question here, consider this as mm, pH. Okay, consider this as this. Okay, now solve the question. What is the most stable product and how it is formed? This is the metal complex. So if you remember my previous lectures of metal mediated synthesis, we have discussed about how to remind you. Have you attended my previous lectures in metal mediated synthesis? No. Okay. It was a previous session of NPTEL. So suppose this is your metal and your metal alkenes, and there is one more. So bond formation will occur. This type of something happens. Do you, if you remember something like this? So answer is A. How? I know answer is A. Yeah, fine. Let's explain the answer. Metathesis. This is what I was telling you. This phenomena. Oh, sorry. This phenomena. Sorry. This phenomena is called metathesis. That I have taught in the previous session, and these sessions are available in my YouTube channel in the NPTEL session. So you can get those from there. Okay, there are a few problems which I have solved on these metathesis reactions. Okay, so this is how it is happening. Metal alkene, in this alkene metathesis is happening. Metal is coming to this position here, see. So again we have one alkene here, one alkene here. Again metathesis will happen, and this is how the product is happening or occurring. Understood? Is it clear? Okay, let's move to the next question. Which is the correct order of rate of insertion reaction into olefin? So there are three types of olefin. They are asking metal will be inserted in which olefin firstly, then secondly, then thirdly. They are asking the rate of insertion reaction into the olefin. Less substituted. Okay. So what suppose less substituted is on the first. Okay, then again we have two options. Which one is correct according to you? Okay. According to you, this one is the correct one. Let's see. You are right. Between hydrogen and methyl, hydride insertion is more favorable. That is the reason this will occur. Okay. And the rate of insertion reaction depends on the nature of alkenes. Less substituted olefin, faster insertion due to the less hindrance. Okay. That's why terminal alkenes are easy than the internal alkenes. Okay. You have given the correct answer. Shall I move to the next question? Question number 5. This is an interesting question. Which is the product X and Y of the following reactions? You need to tell what is X, what is Y. So that means you need to know the mechanism of this reaction, how it is occurring. And even I have one more question. If I react with this compound with iodine, what will happen? This can come to your question paper directly. Do we have an answer for this? It is a very interesting question, I am telling you. Do we have an answer for this question? Okay, fine. Let's go. See what is happening here. Bully. So what will happen? Lithium chloride will come out and these chlorides will be replaced by, okay, then again alkyne insertion, bully out. Okay, we have one more. So what is, but this product is not your product. What will happen? One more, again insertion, and this is the product. So what I have asked, after this product, if we have iodine, what will happen? This is a takeaway question to you. Take it to your home and find it in the books. The reference is again Ilias, and tell me the answer. Understood how it is happening? Okay, good. I can tell you right now if you want, but you need to like see such type of question. What will happen? This metal will leave and the product will be like this. Here iodine. Remaining you fit the ornaments. Okay, fine. Understood. But still you need to go to the books. Choose the wrong statement. Just if I could turn on the charger. Fine. Choose a wrong statement. Alpha abstraction is preferred over alpha elimination. I have already like discussed such type of problem once. Metathesis reaction involve four center cyclic transition state. We have already seen this, right? B is correct. That I know. But what they have asked the wrong statement. So you need to like just read the first question. Choose the wrong statement. D zero metal complexes undergo alpha subtraction. No, they will never. Ah, they will. They will. Alpha abstraction will happen. Alpha elimination will not happen with D0. Okay, attack by an external nucleophile is facilitated by. That is also true. These three are the true statements. This one is the false one. So what they have asked, the wrong statement. How it is false, that I will tell you. It is the explanation for each one. Okay, alpha elimination is preferred. Then alpha abstraction is both are possible. Okay, ठीक है. But this is alpha abstraction is less common, seen very few times. But alpha elimination is favorable and most of the time it have been seen. Okay, metathesis again I have discussed. See alpha abstraction this, okay, and your product is this. From here one hydrogen, okay, and it will be this, and this is your alkene product. So alpha abstraction alkyl group attached to the metal directly takes the hydrogen without formation of metal hydride intermediate. Okay, then again alpha acceptor ligands can take up the electron density given by the nucleophile. Okay, understood. Let's move to the next question. The reason behind the difference in the rate of beta hydride elimination between two complexes. First, tell me which one is the faster. See what is happening in the second one. The it is the cyclic one. Okay, so if it is cyclic, so this is here, right? It cannot rotate. It is fixed. But if you see here, alpha beta is here. ठीक है, it can rotate and come nearby to the metal. So which one is easy? First one is easy and faster. See, understood. Okay, let's move to the next question. Find the correct product for this reaction. Only heating. What can be the product for this reaction? Do we have an answer? Do we have the answer? Okay. No, it is not the correct answer. Okay, let's move to the solution. See what is happening here. This is the correct answer. How it is happening? Here, beta elimination. Here, abstraction. Okay. See, this is the beta position. This will directly take this beta hydride and go away. Means one pH will be out, and here one charge will be there. So here, three bonds will form, and titanium will be directly connected with this. Okay. But beta elimination is not possible there, but abstraction is possible. Beta elimination के लिए hydride should come here. That is not possible. Why? Because Ti is d0, and we have already discussed here. See, where here abstractions हो सकते हैं, but elimination नहीं हो सकते हैं, है ना? So this is how it will go. And here also Professor Maiti have explained this type of mechanism for this reaction, and reference is also there. So we can directly, can we play it? uh, I do not know how to play it. Wait, it should be played. Okay, just a minute, I will play it. Where you see that this diagonal, now if you look at this diagonal and zero, we have to 4 plus, that will 4 plus, that is then zero center. Now I will know this this hydrogen formation should have the defect ability. So this process is not likely to happen at the center where you have a reasonable phase. Since the regional mechanism having a little hydride bond formation is not very efficient, and therefore what we can say in this case, particularly is the classic example of the data. Okay, understood. Understood how it is happening. Okay, let's move to the next question. Uh, what will be the product A and product B for the following reaction? Tell me the answer for this. See, this will happen like this. Okay, same as bully. Mg will take these chlorines. MgCl is out. These will come as a ligand. Fine. Same as bully here. Yeah. Where? Like this. Okay. This will form, and this with this reaction, we remember we have already discussed such type of reaction. If you remember, just only 2 3 questions back. So what will be the product here? Tell me. This Cp2 Ti PME3 twice, and then Cp2 Ti this. Okay, so this one is the correct answer. Understood how it is happening here? Let's move to the next question. This is the final question and it is an interesting question. The rate of the following reaction varies with the ligand 1's POR3. Okay. When R is 4-methylphenyl, rate is 6 into 10 to the power minus 10. When R is 2-methylphenyl group, the rate is 4 into 10 to the power minus 2. What is the most probable rate determining step in the catalytic cycle? Do we have an answer for this? Sorry. Do we have an answer for this? The answer is with the ligand, the R group. Okay. Shall I tell? See here. What is happening? This is one, the fourth position with the second position. One, two, three, and four. Okay. So if we see, second position creates more steric crowding than the fourth position. No steric crowding. Okay. Whenever the reductive elimination depend on the steric crowding, so RE is the faster with the steric crowding. Okay. IDS is reductive elimination. Understood? So that is why only, see here, the rate of this reaction is increased. Okay. With this case, see, this is the steric one. Getting my point? So finally, it was the last question. I have left you with a problem, which I suppose you will find in the book. Though I have explained, but still I want you should go through the book. Okay. Is it clear? Everything is clear.